right, we should be live. And let's focus a little bit better here. So we're going to be analyzing graphs. This is a really important lesson because it goes over a lot of really useful graphs. So let's look at this first one here. It's the one you're probably most familiar with. Let's focusing, having a little focusing here. There we go. Looked kind of blurry on my end. Okay, so this is my straight line. So what is the function type and parent function? Well, this is a linear function, right? Because it's a straight line. So pretty easy on that one. All right, so let's see. Function clues, key features, and observations. What are you observing from this line? Well, like I said, it's a line. That's key feature number one. Generally, there's one intercept. There's one exception to that. It would be if the slope is 0. In this graph, the x and y intercept have the same point. In this one, right there, 0, 0. If a line is horizontal, it's still a function. So let's think about that for a second, right? So, for a line to be a function, that means that none of the x values are repeated, right? So if we have a horizontal line, then the x value will correspond to one y value. If we have a vertical line, it's not a function because then it's just x equals whatever, x equals 2, would be here. And 2 is repeated for the entire like series of all real y values. So let's see. So the parent function for this is f of x equals x, right? So here is 1, and the y-intercept is 0. So just a little reminder: linear function is y equals x plus b, and here is 1, b is 0. All right. Moving on. So this next function is an absolute value. You remember that? Like right over here. So an absolute value function is, and this is the general function. What are observations here? Our shape is a V. It has a vertex. In this case, that's right, because everything's going up. In this case, it's minimum. So the mean is all numbers, and the range varies. It either goes up infinitely or down infinitely. So in this case, it goes up infinitely. What's the range? Right, y values are increasing infinitely for this one. If it was facing down, then they would be decreasing infinitely. So it has a line of symmetry. Through the vertex. and always has one y-intercept, which in this case is 0. So again, the function for this is absolute value of x. We got the parent function. It's kind of the same thing here. There's still a y-intercept and there's still a slope. This denotes, because it's not a slope, it's, sorry, I'm drawing a blank to the word. It's not the slope, it's, well, it's still the slope, but it's the leading coefficient, right? So maybe we'll use an a in this case. I think an a is more appropriate. Since it's the leading coefficient, it's the direction of the graph. All right, what is the next one? Make sure you get all that written out. Sorry, I think I was off the screen a little bit. My camera was lagging. So I'll get that down. Okay. All right. I'll write that down to get the next graph. Set up. All right. Next graph in exponential model. Here. All right, we've seen some exponential curves before. You can see that the slope increases rapidly as it goes towards the end, which makes it exponential. The parent function of this is x. And technically, I like to put plus b, where it's increasing, right? And b is the starting value. And the starting value. So it is an exponential growth because it's increasing, right? It could be an exponential decay if it was decreasing. It's not. So as growth increases, y increases more quickly. 1, 2, or no x-intercepts. And then always 1 y-intercept. Drop that down. All right, next one here. This next one here is in the shape of a parabola. This one has a vertex and minimum. It's the lowest point. It would have maximum if it was facing away. Function here. F of x equals x squared. Has a line of symmetry. It can have 1, 2, or x-intercepts. We went a lot of these, so you should be pretty comfortable with this. Intercept. Okay. So we're doing a lot with this. You should be fairly comfortable with them. Okay. This next one, I went over these a little bit. This next function is a square root function. So you can see that it's all positive values because we talked about this. Any negative values make it invalid. So the reflection and rotation of part of a quadratic function. So no negative values for x or y. There may be none or one x and y-intercept. So these graphs always have an endpoint that's here. In this case, it's a minimum. Make that green. Endpoint, endpoint. And in this case, it's a minimum, but could be a maximum. Minimum. There we go. Domain and range restrictions, and no symmetry. Right, this is not symmetrical. You could fold anyway and have it touch itself. Yep. Yep. All right. Next. Cubic. So you can think about that. What do you think a cubic function means? I'll probably have something to do with cube. And if you're thinking like a cube, like a square, it does have something to do with that. But we're just going to talk about to the third root right now. Right, if you think about a square with 3 sides, it would have it's like the volume. It'd be one side by one side by one. That's how you take volume. That's why a cube has 3 dimensions to the third power. Okay. Overall shape is a curve that rises and appears to level off. So see, it rises, levels off, and rises again. So curve rises, levels, rises. Parent function has 1 x-intercept and 1 y-intercept. They're both 0 at this point. So 0, 0. But don't have to write this shift over this way. Parent graph skims across the other side of the x-axis. So x-axis skims it. Where's it? What else do we notice? If the leading coefficient is negative, the curve reflects across the y-axis. I always recommend using like Desmos and plugging these in and playing with them. It's a really good way to see what happens to graphs when you manipulate them. How the x-axis changes, how the y-axis changes, all that jazz. So I would definitely recommend, if you're struggling to see what these things mean, plugging this into Desmos and checking it out, because it's a really useful tool. All right. And last but not least here, let's make sure my camera angle is good. There we go. All right. So as you can imagine, there's a bit of pattern here. Last one was a cubic function. So this one is a cube. or f of x equals 3 of x. All right, so what do we know about this one? Overall shape and reflection, it's an S curve, right? Kind of looks like a sideways S. Sideways S. The domain goes forever this way and forever this way. So domain, all real numbers. What else? So how about if x is negative, y is negative. If x is positive, y is positive. So x negative, y negative. X positive, y. Oop, terrible sign. There we go. All right. Got it. That's all you need for general graphs. All right, and that was a bit of a recap. We've gone over this before, but it's really useful. You use this table to refer back. Whenever trying to think how to write in something, it can be really useful to have a graphic representation with a parent function. So that way you can see, how to change if we move it up if starting value is not 0, 0 for any of these. All right, should we get into an example? Let's go over a little. Dun, dun, dun. All right, let's get 20 minutes. So, not a little, you can see the whole thing. So, if Bart has a summer job that pays a certain rate for the first 40 hours of each week and time and a half for any overtime. So that's pretty normal. This is a real life scenario. If you work 40 hours full time, you usually get paid time and a half. That would mean you get paid for what you're working plus half that as well. So say you work an hour, you get paid for an hour and a half. Make sense? Make $8 an hour. Overtime, you would make 8 plus 4. So overtime is nice, unless they tax you more on it, then it's a pain. Which is a really good function to look at if you're going to be working overtime. Oh, sorry, my computer is being very slow. Oh. It's whatever. So what is the question? Let's get the questions. What's the question? Write the function in analytical or symbolic form for the graph in example 1. What would the equation be? Well, let's see. Looking at it, it is a function because it shifts. I think that it's probably 2 linear models. So I start writing. I'm going to do it over here. I'll do it over here. So for A, for our function, let's look at this bit first. Okay, so it goes from 0 to 40. This is a 40-hour job. Okay, so it changes. Use a different color. Changes at 40 hours here, right? Okay. So the first function is going to go to this point. Our intercept is here, 0, 0. Okay. So that b equals 0, 0. So let's see, how does it change? And it might be a little different based off what you see. So I like over here because it gives us this point. So that's probably going to be the easiest place to find the slope, right? So let's go ahead and find the slope. So m is equal to the change in y over the change in x. So our first y is this, and our second is this. So change in y, 198 minus 0, over change in x, minus 0. And that can be reduced. We have 198 over 22. All right, I'm going to start by reducing it by 2. Well, actually, let's do 198 divided by 22. It's 9. Wow, did not expect that. All right, so our slope is 9. So we have y equals mx plus b, or b is 0. It's just the y value. So plus 0. We don't need to write that. Okay. So let's look at our next little line, the next segment of line here. So I'll go ahead and put this for this. Y equals 9x. For this part. So I only have green today. Usually I like to try and have a couple different colors, but I did not bring them. So next we're going to look here. What is the slope? It's typically for this whole line, right? But we're going to use these points to figure out what it is. So let's find a slope again. M equals 7. I can't tell if it's 765 or 785. Let's see. It could be either one. Let's go 765. Minus 630 over. So data being printed out poorly can really affect your results, can it? So 765 minus 630. Oops. Do that in my head. I don't want to. 135 over 10 is equal to 27 over 2. Which I guess we can have a number. I like to leave slopes and fractions. It makes it easier to graph. But let's go ahead and do that. So, and then what would b be? So we have y equals 27 over 2x plus b. So this one's a little different. Like the original one, it was really easy to see what the intercept was because it's given. For this one, you have to actually go back and plug one of these points in. It doesn't matter if you put this in or this in, you're going to get the same answer. So the first point, do 630 equals 27 over 2 times 60 plus b. Now you see we have one variable, right? We know that this point is on line, so that's why you can plug it in. You know that. But this is not the time. Is that right? Negative? Yeah, that makes sense. So b equals negative 180. So therefore, this equation for a little is y equals 27 over 2x minus 180. And think about it, right? That makes sense. Because if you look at this line, it would hit the y-axis somewhere below 0. So it makes sense that it's negative. So that's always, it's good to do mental checks like that. And just make sure that you're understanding, you know, make sure that your answer actually makes sense. And if it makes sense, then you probably have the right answer. Sometimes it's wrong, but for the most part, if your answer makes sense, it is correct. All right, so what is the equation for the second piece? Oh, we figured that out. So this was actually part B, sorry. So that was part B, this was part A. And we'll go ahead and I'll write that y equals 27 over 2x minus 180. All right, part C. What are the domain restrictions for the context? Let's see. So domain is x values, right? We're talking about how many hours he worked. So he can't work less than 0 hours, right? So part C. Can't work less than 0, and he can't work. I mean, you could think, let's see, how many hours are in a week? I think it's, so, I don't know what I'm thinking. So 24 hours a day, right? 24 hours a day times 7. So can't work less than 0 hours or more than 168. And to work 168 hours, he would never be able to sleep, wouldn't be able to eat. He would literally be working 168 hours. So that's not exactly the right thing. You could think, well, what if he needs to sleep 8 hours a day? What if he only needs to sleep 6 hours a day? For this, for all intents and purposes, I'll say between 0 and 168 hours, even though we know 168 hours would probably kill him. So he'll be incredibly mentally unwell if he works 168 hours a week. But technically, that's the most hours he works. Explain the domain in context of the problem. Oh, another thing that could restrict the hours is maybe the company says, you know, it doesn't tell you this, but if the company said you can't work more than 80 hours a week, that would be a restriction. So the domain would be 0 to 80. All right, so explain the domain in context of this problem. We just did. D. Domain is hours worked. And then this was part A, and this was part B. Domain is hours worked. Okay. Awesome. So I'm going to go ahead and call this lesson. There's a couple of other problems here looking at functions like this, and you'll refer back to that, referred back to in the beginning and say, well, what type of function is this? And I'm not going to go over all of it. And say, well, I know it's the cubed root function, right? And you talk about transformation. So it shifted down and over, or I guess maybe it just shifted over actually. It's still symmetric this way. So it shifted to the right by 1. So its function type is a cube root. Parent function is f of x equals 3 root x. Transformations, shifts right by 1. Okay, and the equation here, so I would check this in Desmos. I think that shifts, I haven't done the cube root function yet, but I put shifts for the cube root. Let's go ahead and look. It's just to the right, it should still be minus, but I'm going to check before I elaborate. Make sure that I have answer before I explain it here. What other transformation? So it'd be interesting to note, I believe that here to here, it doesn't look like stretch at all. It's somewhat difficult to tell what's given. It could be stretch. But what we have, it looks like it's not. Oh gosh, sorry, my computer is being super slow. So what is this start? Sorry, give me a second. Yeah. There. eventually my computer will... It doesn't even have... Interesting. Oh, okay. Because I skipped to problem 5. That makes sense. So there's other with that. But we can go back. This is one we haven't done, so I think it's good that we're doing this one. Aha. Okay. Yep. Okay. So I was right. So because it shifts to the right by 1, it affects the x directly. So you still have the q root. Now it's a x minus 1. Because remember, if it's just right or left, it always affects the x. Like you keep it in parentheses because it's affecting this part. So if it's left, it would plus 1. Lovely. We've done a lot with parabolas, so I'm not going to do number 6. Like I said, I'm going to conclude that lesson. Please play around with Desmos or some other graphics so you can see what transformations look like if you are struggling. Awesome. Any questions?